to the announcement of the 2022 Nobel Prize in Physics, you've probably never heard of quantum entanglement. The prize was given to physicists Elaine Aspect, John F. Clauser, and Anton Zeilinger for their work in quantum entanglement and quantum teleportation.
Likely, the idea of teleportation that popped into your head was akin to that of a sci-fi movie. That teleportation concerns the transport of matter, while quantum teleportation concerns the transfer of quantum information.
To understand quantum physics, we're going to have to start really small.
Classical mechanics, the physics we know and learn about in school, considers the macroscopic world, meaning things we interact with every day. But there are much tinier particles that make up the world we know. This includes electrons, protons, and neutrons in atoms, and photons in light beams. The laws that govern our world break down as we zoom in, meaning that the classical mechanic principles you learn from school don't work on the quantum level. In our world, the lights are either on or off. Things are either black or white, dead or alive. But on the quantum level, there exists the idea of both at once. Take a look at an atom, but not this one. Instead of a definite orbit around the nucleus, let's imagine an electron cloud. This represents the area where an electron could be. It could be here or there. It could be anywhere at once. The idea of superposition. In quantum physics, you might hear the phrase, collapse of the wave function. What this represents is the moment a quantum system exits that state of superposition and lands on one in being measured. From a classical perspective, quantities are definite and exist before they are measured. But from a quantum mechanics perspective, it is the moment that it is measured that a quantity comes to be. Imagine a particle with no momentum. From that particle, we take two photons, either spin up or spin down in a state of superposition. By conservation of momentum, we know these two daughter photons from the original must have opposite spin to cancel out. In measuring the spin of one particle, we will immediately know that of the other because they are opposite and entangled. While no longer a part of the original particle, these two photons have the memory of existing as one, no matter the distance between them. It doesn't mean that this information traveled faster than the speed of light, it is just that they are entangled, and we will always know the other instantaneously. As for the 2022 Nobel Prize recipients, they did achieve quantum teleportation in a laboratory setting, but knowing quantum theory, it wasn't like that on the Enterprise. It does mean they transferred the quantum state of one particle to another. While we may not have the ability to travel faster than the speed of light, quantum information is an amazing field to study, though it does require some more untangling.